This is the video for Geometry, Chapter 11, Section 2. We're looking at area of trapezoids, rhombuses, and kites. So remember, a trapezoid has exactly one pair of parallel sides. So these would be the sides that are parallel. And the sides that are parallel are called the bases. So this would be base 1 and this would be base 2. It doesn't really matter which one you call 1 and which one you call 2. The height of the trapezoid is no different than the height of a parallelogram in that it must be perpendicular to one of the bases through the other base. So that is going to be your height. Again, you will not use this as the height because it is not perpendicular. Also want to remind you that a trapezoid could look something like this. Again, because these sides are parallel, those would be the bases. But if this is a right angle, then this would be the height. So the height has to be at a right angle to one of the bases. So the formula is pretty straightforward. It's 1/2 times the height times the sum of the bases. So you probably want to figure out what the sum of the bases is first, and then you're going to just multiply that times the height and times 1/2, which remember, multiplying by 1/2 is the same as dividing by 2. So here's an example problem. We know that the area is 42.5 units squared. We know that one of the bases is 10, and we know the height is 5. So we're actually solving for the other base. So this is our variable. So my area is 42.5, and that is equal to 1/2 times the height, which is 5, times 10 plus the other base, or a base plus 10 is the same thing. So I need to figure out how I'm going to solve this. So I need to get this B2 by itself. And so I really need to get rid of this 1/2 times 5. And so 1/2 times 5 is the same as 5 over 2, because 5 is 5 over 1, times 10 plus B. So now to get rid of the 5 over 2, we should know this. I'm going to multiply by 2 over 5 on both sides. 2 over 5 times 42.5 is 17. So 17, those cancel, is equal to 10 plus B. Subtract 10 on both sides, B equals 7. So the other base would be 7. All right, our next example is a rhombus. The formula for area of a rhombus is 1/2 the product of the diagonals. So the diagonals are the segments that connect non-adjacent vertices. So those are your two diagonals. Remember, in a rhombus, the diagonals intersect at a right angle and they bisect each other. So all of those are congruent. So again, you're just going to multiply the diagonals and divide by 2. So in this rhombus, ABCD, that would be 1/2 times AC times BD. So you're just multiplying all those three. Again, multiplying by 1/2 is the same as dividing by 2. Last formula is for a kite, and it is the same formula as a rhombus. But remember that a kite is different than a rhombus, so make sure you don't, think about it exactly the same way. The diagonals do intersect at a right angle, but the diagonals don't bisect each other. These pieces are congruent, though. And so, again, the diagonals, the formula would be 1/2 times AC times BD. Those are the formulas, and so you'll be able to practice finding areas as well as solving for perhaps a length of the diagonal or finding a height of something if you're given the area using algebra.